Okay, hey algebra students. Welcome to our second day of graphing. So we are going to be looking at graphing in factored form today rather than in vertex form. For this one, it's not going to be too much of a jump. For us, it's, pretty comfortable since we've already talked a little bit about why factoring is useful for graphs. Now, being Monday, you guys had your homework, which was the worksheet over the weekend. You might have questions about number 6 and 7. Number 6 and 7 are definitely really similar. These are a little bit of stretching questions. So if you were having a little bit of trouble doing them, if you had to consult the key, no big deal. We'll talk about them tomorrow on Tuesday. As long as on the homework you understood like the two straightforward graphs, right? Seeing the stretch was something we talked about in the video. And it kind of came up in number 2 as well. And then the number 4 was graphing using completing the square. So that one you should be able to do. And number 5 shouldn't be too big of a stretch using the ideas on the front page with number 3. So we'll definitely talk about 6 and 7. Hopefully you feel better about 1 through 5, but we can talk about any of those. So make sure you pause the video to write out any of the titles that you need in your notebooks. I believe I should have a PDF available so you can print this if you prefer. The standard look of factored form has a x minus, I'll just put maybe b and x minus c. So really similar to how you're used to factoring, except for we're thinking about there might be a GCF in front. And then b and c are representing the x-intercepts. Okay, so we'll look at an example here. So that means my zeros, or I prefer calling them x-intercepts. If I look at my equation here, right, think about we're solving when is this equal to 0, right? That is basically saying when is your y equal to 0, which means it's your x-intercepts. Okay, right, height of 0. From each of these, we see x could be 4 or negative 2, right? A lot of you guys have noticed the opposite idea. So my 2 points, and I'll write them there as coordinates, are positive 4, 0. And then we have negative 2, 0. Okay. Now let's see, the other thing I know is there's not a coefficient, right? Which means we're not stretching at all. Because it's positive, it's facing upwards. But now the question is, how do I get that vertex? So here's the idea. If we look back at our graphing quadratics in vertex form, right, here's, let's look at this one maybe. So if we think about the graph of a parabola, one thing we talked about, remember that yellow line represented the axis of symmetry, right? And how if we found points on the right side, we could mirror them and get them on the left side. And the vertex being in the middle, that green point. So if I'm looking for the vertex, I know that the vertex has to be on the axis of symmetry. So that might be a really good thing to make a note of here. The vertex is along the axis of symmetry. So if I'm looking here, this is 1, 2, 3, 4, 5, 6. Right? 6 divided by 2 is 3. So that means my axis of symmetry should be 3 along. 1, 2, 3. Looks like it's at x equals 1. Right there in the middle. So my axis of symmetry, I'll maybe put it as a little note down here. Axis of symmetry is at x equals 1, right? That's the line right there. So that means that my vertex has to have an x-coordinate. Oops, let me get back my pen. Has to have an x-coordinate of 1, right? If I want to find my y, I'm just going to make a table and plug in 1. So I've got 1 minus 4 times 1 plus 2. 1 minus 4 is negative 3 times 3. That's going to be negative 9. So 1 comma negative 9 should be right down here. And then if I want to get another point, I'm just going to choose something a little easier. One question I did get asked a lot for the vertex form, when some people were working on the homework, like for instance on number 1 and 2. They were like, okay, so I can find the vertex, but then how do I know what values to plug in? Remember, once you get that vertex down there at the bottom, you want to plug in a couple of inputs just past the vertex. So I normally plug in 1 and 2 bigger. So that's why I plugged in 2 and 3 into my table down here, if you look over here. So you want to go just past, because if you go too far with the quadratics, with the squaring, it gets pretty big. So I normally plug in 1 to the right and 2 to the right, and then I mirror them, is typically my strategy there. So I've got my vertex, right? And now I want to plug in 1 to the right maybe. So number 2, 2 minus 4 times 2 plus 2. That's going to be a negative 2 times a 4, which is a negative 8. And remember, what we were noticing with quadratics, this one doesn't have a stretch. Right here I'm just doing the mirroring, right? Now what's really nice is that this one does not have a stretch factor. If we had a stretch factor, we would see it as a coefficient right in front. Remember, that's your stretch here. And so remember, with the first point, even if you shifted it around, moved it right, left, up, down, it still is over 1, up 1, over 1, up 1. If it's over 1, up 2, or down 2, that would be a stretch of 2. So that's how you can tell the stretch. Okay. And it looks like I've already got my y-intercept. Notice the point at 2, right? The mirrored point gave us that point. So 0, negative 8. If you needed to find this and you didn't have it, you would plug in x equals 0. That's just if you're missing it. If you happen to plug it in, then you're good. So I've got my factored form right here. I'm just going to rewrite it, and we're just going to think about what the other forms would be. Standard form would be all multiplied out, right? So x times x is x squared. X times 2 is 2x. Negative 4 times x. And then negative 4 times 2 is negative 8. Plug or combine those like terms. And that's going to be minus 2x minus 8. And then let's see, our factored form we've got, and our vertex form, we would want to think about what that would be in vertex form. So what I might do is, let's see, I am going to maybe do that over here, maybe on my side. So I'm going to think about vertex form, or excuse me, vertex form. I'm going to think about completing the square, right? I have x squared minus 1x minus 1x, because remember you want to split it in half. If that middle term is not even, it's not a good strategy for using completing the square. That did come up in your factoring mini quiz. Some people were saying that completing the square is a good strategy for something with an odd number, and that wouldn't split up very nicely. Okay, minus 1, so 2 negatives make a positive 1. So I'm going to write it out, plus 1. And then some of you guys like to do plus 1 minus 1, right? We still have that negative 8. Notice that doing that, this is in essence adding nothing, because you've added a 1 and taken away a 1. We're going to regroup that though, and write that as x minus 1 squared. And then we're going to put these two together, make it negative 9. If you prefer to not do the plus 1 minus 1, you could view it as plus 1 and what number create a negative 8, and it would be a negative 9. So you can think about breaking apart the negative 8 if you like. So I'm going to write my vertex form. Notice the vertex does match the negative, or the 1 to the right and down 9, right? That matches nicely. Okay. So the next thing says, how can you find the vertex from standard form? And from standard form, it's all multiplied out. It's kind of tricky to think about how you find that vertex, right? And there's actually something kind of interesting. So here's what I'm going to do. I'm going to show you guys where this special idea comes from. I'm going to, on the side over here, I'm going to use the quadratic formula. And I'm going to use the quadratic formula to kind of illustrate a point. So I'm going to solve for x using the quadratic formula, right? That should give us our 2x intercepts. And I'm going to use my standard form. Writing the 1 as the a, so I can see that. So a is 1, b is negative 2, c is negative 8. And I'm just going to plug everything in. So x is equal to opposite of b plus or minus the square root of b squared, right, minus 4 times a times c. And I might move some of this stuff over just so I have room to simplify. So quick move. I'm just going to try and squish this down a little bit. Okay, now I think I've got enough room to move this up a bit. Okay. All over 2a. You guys for a second might have been like, uh-oh, you forgot something. If I simplify this, 2 plus or minus, underneath my square root, I'm going to get negative 2 squared is positive 4. 2 negatives make a positive 32, all over 2. That's going to simplify to 2 plus or minus 4 and 32 make the square root of 36, right, over 2. So I'm going to just kind of switch that to a 6 because I know that that's the square root. Okay. And then remember that we can divide everything by 2, right? I'm going to just scooch this over just a little bit. I'm just going to maybe shrink this just so I can see everything in the frame because I want to point out something in the graph. Okay, so I'm just going to make that a little smaller. So remember dividing both by 2. 2 divided by 2 is 1. Plus or minus 6 divided by 2 is 3. So here's what's kind of interesting, right? You notice the plus or minus idea gives us the 2x intercepts. That has to come from somewhere. Notice the 1 matches with our line of symmetry. And then from that line of symmetry, we go to the right, we add 3, and we go to left, we subtract 3. So we go 1, 2, 3, and 1, 2, 3. So what's really, really interesting is this 1 right here. That corresponds to the x value of our vertex, right? Or you can also think about it as the line of symmetry. So if we want to find the line of symmetry, it actually corresponds to this 1, right? And that 1 came from, we did this over this. So if we think about what the formula is equal to, right? This is opposite of b. So opposite of b divided by what was on the bottom, 2 times a. 2 times a. And that corresponds to your line of symmetry, which also is in essence your x-coordinate of your vertex. So it's really quite interesting that what the quadratic formula does is it finds that line of symmetry and then it goes right and left of the line of symmetry in order to find those x-intercepts because of the mirroring idea. So if you want to find your vertex, it's negative b over 2a, comma, and then if we call our function f of x, plugging that in and finding the output, right? This is just like you plug it in. Okay. And so what we'll do tomorrow is we'll kind of go over this, and we'll go over any questions in the homework. And then on this next page, I have a good practice for us to look at, where we look at the same equation in all these different forms, and we kind of talk about where we can pull certain graphical things, how we can use that form, right? So we'll do that and maybe a couple of practice graphing in standard, or in factored form.